All right. So, hello and welcome. My name is Roman Chomko, and let me start by sharing the slides. And I will go over the slides. So, please ask questions if you have any. Stop me at any second so I can provide more details. So, let me start by sharing the screen. All right. So, here we go. So, as I mentioned, my name is Roman Chomko. I'm an associate professor of teaching at the Department of Electrical and Computer Engineering. I'm also the chair of EE Undergraduate Committee, and I will be introducing you to the world of electrical engineering and electrical engineering education at UCR in particular. So I didn't know how to call the presentation, but I think this name that I provided in here would be probably the most descriptive. Electrical engineers change the world. Well, this is true because electrical engineering is the driving force for technological and social advances. So anywhere you go, anywhere you look, anywhere these days you touch, most likely something of that was done and created by electrical engineers. So in general, electrical engineering can be treated as a subject of engineering which covers electronics, electromagnetics, and engineering and electricity. So in general, we call it EEE or triple E. And what electrical engineering is dealing with? Well, information systems, signal processing, sensing, data transmission, actuation, and storage. Also, electrical energy and power, which is related, which deals with generation of power, transmission of power, conversion of power, storage. So those are just samples of what electrical engineering is dealing with. But I will discuss. I will provide more details in a few minutes. Well, electrical engineering is covers many subjects, and substantial knowledge is required by electrical to be a successful electrical engineer. So knowledge of mathematics, knowledge of programming, how to design algorithms, how to design systems, physics of systems and processes. All of those things are required, is a required background to be a successful electrical engineer. So electrical engineering is involved in the design of large systems and integration, embedded software, hardware modules and units, circuits, materials, and devices. So, as I mentioned already at the very beginning, that you just name any object, any subject, it wouldn't exist without involvement of electrical engineers. And actually, we have exciting times in electrical engineering, and also, for that matter, in computer engineering. So, nano devices, which are pushing the Moore's law, so which provides a way how to create faster, lower power computer processors that contain many cores. So, for example, how it is achieved. So, Intel back in 2011 created a technology that create devices on a nanometer scale. So, what is a nanometer? So if you have, and I'm sure you are aware of how materials are, the content of materials, right? So we have atoms, which have ions and electrons spinning around uh, ions, right? So now, if you take the distance between the electron and the ion as a unit, so 10 times that distance is a nanometer. All right. So think of it like this, that we are capable, even starting from 2011, we were capable of creating devices 20 times the distance between electrons and ions. This is a very small distance or a very small size of devices. Well, in 2017, Intel actually introduced a new technology, which is called 14 nanometers. And it continues to be scaled down even further. it got to the point that now we can actually create quantum devices. All right, so probably you've heard about quantum computing, right? So quantum computing is just knocking on our doors, which will exponentially increase of the speed of processing that we have right now. The next step, big step, would be the creation of three-dimensional large integration integrated circuits. Think of like this, as far as memory are concerned, so we have two competing technologies now, hard drives and solid state drives. Back in 1998, I was one of those people who actually demonstrated the capability of storing about 100 gigabit of information on the inch squared of the hard drive. Well, Seagate actually did much better, and they introduced technologies that exceeded the size of storage was increased to 1 terabyte per inch, terabit per inch squared. And in 2016, actually it exceeded that, 60 terabit. Well, but solid state drives actually were not, like far behind. And the Axer Drive company, for example, in 2024 demonstrated a solid state drive which contained 100 terabit of information. Well, the cost was kind of quite high, $40,000, but it is always expensive when the technology is just introduced. So eventually, of course, this will drop down probably to a few dollars. As we know, like USB drives, flash drives, they're not very expensive, but initially they were expensive. So $40,000 it is today, but probably in 10 years it will be $4 to $5, maybe. Next, wireless broadband, mobile internet, Internet of Things, robotic cars, autonomous driving, electrical and hybrid vehicles, sensor networks. This is all what we are dealing right now in electrical engineering. So exciting times. As far as EE earning potentials, well, if you graduate from with a bachelor's degree, most likely you would expect on average to earn about $60,000. Well, this diagram is a little bit dated. Actually, it is 5 year old, I guess, because the new data are not available yet. But even $60,000 for a person graduated with a bachelor's degree is quite a substantial boost in earnings. Uh, well, if you become a senior engineer, for example, electronics engineer level 5, so on average, your salary would be increased on average to about $120,000. Of course, salaries will be much higher if you are an executive, which is not rare. So, for example, a top division engineering executive would earn the salary would be starting from $170,000. Well, in this case, 143, right? But on average, it would be about $170,000. If you are top engineering executive, it would be much higher than that. All right, so earning potentials are quite high. Now, as far as electrical engineering within Bourne's College of Engineering at the University of California, Riverside, well, the ECE chair is Professor Ertem Tansel. I'm an undergraduate advisor, as I already mentioned, and we have plenty of student organization. The most famous one and the largest probably is related to the Institute of Electrical and Electronics Engineers, or the so-called IEEE. And we have an IEEE student chapter, which pretty much majority of students in electrical engineering are part of this chapter. And we have plenty of other student clubs. All of them can be found by following this link, which I provided in here. So simply go to the ECE department website, and then you will be able to find the link to all student organization starting from that main page. Within electrical engineering, we have a number of focus areas. So if you're interested, for example, to deal with signals and systems, right? So you would take more classes or the so-called technical elective classes which are related to this subject. Even though um, in your transcript, we don't officially indicate your focus areas because you are, after graduating from from ECE, with in the electrical engineering program, you would be able to deal with any subject. It is just that we tailor your interest to particular subjects. So again, it doesn't matter what focus area you choose for your technical electives courses, which you have to take during the last 2 years of classes. You're capable of doing any job in any of the focus areas, except that, like you can take more technical electives related to the area of your largest interest. So again, we have six focus areas. The first focus area is communication, signal processing, and networking. The second one is control and robotics. The third one is embedded systems and VLSI, intelligent systems, nanotechnology, advanced materials and devices, power systems, and smart grid. So I'll talk briefly about all of them. All right, so let me move to another slide. So if your interest is in communications, for example, you would like to design cell phones or iPads, iPhones, Android phones, or you want to deal with optical networks, or you want to do more to be more on a software side and deal with compression and encryption of information, or speech recognition, or dealing with navigation systems, that would be a good area for you. In fact, many uh, large companies related to government, such as Raytheon, Northrop Grumman, for example, Lockheed Martin, aerospace company, they hire our students in large numbers, especially those students whose focus area was in this area of communications, signal processing, and networking. A very popular area now is control and robotics. So even though within BCOE we created a new program, which is called robotics program, it was actually a spin-off of this focus area. So it was a collaboration between electrical engineering, computer science, and engineering, and they came up with a new program, robotics program. Again, it was a spin-off of this area, but we still prefer to keep robotics-related things such as control within the EE program. So if you want to deal with unmanned vehicles, robots, plant automation, automobiles, robotic surgery, for example, developing new medical devices. Uh, so that would be your area of interest, most likely, or your focus area. If you're interested in designing new chips, for example, you want to design new circuits, or as I mentioned, three-dimensional circuits, or you want to deal with game consoles, so for example, you would like to deal with microcontrollers. So in this case, you would have to have embedded systems and VLSI as your focus area. A very interesting one. Many things in here, many topics are directly related to computer engineering. So if you are undecided, for example, to go directly to deal with electrical engineering or to deal with computer engineering. So we have this focus area right in the middle. So it is both EE or electrical engineering related and computer engineering related. Well, as you know, new technology will always appear if there are new materials. So if you want to be on the edge of technology, and as I mentioned already, new technology is based on the availability of new materials. Well, nanotechnology, advanced materials, and devices would be the best choice for a focus area. In fact, if you are involved in this focus area, so you would learn and do research, for example, related to synthesis of advanced materials, again at nanometer scale. You would be able to design efficient solar cells for energy generation. You would be able to design new types of solid state and high density memory devices that I already mentioned. If you want to be, on the other hand, involved in nanomedicine, well, this is a focus area for you. Drug delivery systems, for example, design of biomedical engineering devices at nanoscale. So this is a very interesting area. Recently, we introduced an area which is called a focus area, which is called intelligent systems, which is directly related to the word artificial intelligence. All right, so it covers many areas now. It is it is a very hot topic these days, and by intelligent systems we mean many things: artificial intelligence, pattern recognition, computer vision, image processing, video processing, autonomous car driving, speech and facial recognition, for example, smart homes and intelligent transportation systems, recommendation systems. Everything what I mentioned is related. It goes under a single umbrella, which we call intelligent systems. So if you are interested to be designing, for example, autonomous driving algorithms, for example, that would be a good choice for a focus area. On the other hand, if you want to deal with power, you want to deal with renewable energy, you want to deal with a smart grid, power electronics, electric motors and drives, well, we have that covered too in the power systems and smart grid focus area. So these are six focus areas that uh, we identified as the most important for our undergraduate students. Most likely, eventually, we will introduce a few more. For example, we are thinking to introduce a new area of circuit design, the area related to quantum computing. So that's the future. Maybe it will happen in a couple of years, maybe next year. We are working hard to satisfy all needs of electrical engineering. Now, as far as EE major requirements, so you would have to take lower division classes and upper division classes. So for the lower division classes cover classes in mathematics and physics, also, which, as you can tell in here, Math 45, also Math 9A, 9B, 9C, 10A, 10B, plenty of mathematics, but there is no electrical engineering without mathematics these days. Without uh, serious knowledge of mathematics and physics and programming, well, we cannot consider, electrical engineers cannot be considered electrical engineers. Maybe before electrical engineers existed like a separate brand, I would call it like that, of engineers. But these days, it is almost impossible to progress as an electrical engineer without this background. So that's why we have these courses as required core courses. And 77 units you would have to take of upper division classes. So among them, you will have 24 units, or in other words, 6 classes of technical electives. And they are again subdivided into focus areas. So here's a chart of the focus areas. So in order to be considered in a particular focus area, you have to take 2 technical electives as required courses to be considered to be in the focus area. So for example, for control and robotics, you would have to take 2 classes, EE 105, which is design of control systems, and EE 144, which is related to foundation of robotics. So these 2 courses you would have to take in order to be considered in the control and robotics focus area. More than that, you would have to take 2 additional courses from elective courses indicated under control and robotics focus area, and 2 additional courses from any other focus area of your interest. Okay, so this is to say, to be considered in a particular focus area, you would have to take 2 required courses, 2 required technical elective courses, 2 additional technical elective courses from the list, which is indicated under each of the focus area paragraphs, and any other 2 courses from any other focus area. So it may be from the same focus area or maybe from some other focus area. So in many cases, students are taking technical electives, for example, related to computer vision, even if they are in power systems, right? Or they take classes, for example, advanced electric circuits or RF design of RF circuits, even though they are in intelligent systems. So we have plenty of flexibility as far as what classes students have to take in order to graduate. Well, we create course plans for all students. So if they follow exactly the course plans that is, for example, shown in here, we guarantee that students can graduate in 4 years. So this is a typical course plans that we have for students. So again, if you follow it, you will be able to graduate from UCR within 4 years, even without taking any classes during summers. Of course, in order to succeed, you will have to uh, strategize your education or the way you study. So, as I mentioned, electrical engineering involves a lot of mathematics and physics. So, for example, you cannot succeed in EE 116, which is engineering electromagnetics, without knowing vector algebra or how to take surface integrals, which are covered in, for example, mathematics class Math 9C. Some EE specialization, some focus areas require more math and physics than others, but overall, all electrical engineering have to have a very deep background in mathematics and physics. So you would have to work hard. So the rule of thumb would be to spend 3-4 hours per week per unit. So which means if you are taking any quarter 12 units of classes, which is approximately 3 courses, you would have to spend 36 to 48 hours per week of studying. So you'd have to study ahead of time because lectures typically is not enough. So if you want to be, following the material and to do all homeworks on time, well, it is a general suggestion to read information or material ahead of time. So high GPA is very important. In some cases, it is very important if you want to continue your education. For example, if you want to get a master's degree or you want to apply for a PhD degree, then of course your GPA should be extremely high. However, even to get a job in industry, like your GPA cannot be too low. So, for example, if you have there's a difference in engineer with a GPA 2.0 and 2.8 is quite substantial. So typically the big mistakes that you would have to avoid would be to underestimate program difficulty, not studying enough hours, watching, too many movies or spending too much time playing video games or academic dishonesty. This is something that our students would have to avoid in order to be successful. At the end of during the last year of school, in your senior year, all students would have to go through the capstone project design. So that class is actually split up between 2 quarters, and you would have to come up with your own project that you have to create from scratch. It must be fully functional and it must be commercial-like, which means, like if you work on it a little more, you can actually sell it. So examples of capstone projects are shown in here, even though the list is not exhaustive, but it demonstrates what students are capable of doing after in their senior year. So, for example, Bluetooth wireless electrocardiogram monitor, or 3D printer, uh, SMD surface mount devices, component placement machine, automated warehouse, robots of all different sorts, autonomous navigation, smart shopping cart, Amazon style, wireless audio transmission, and so on and so forth. So as you can tell, that those are very advanced projects that students are dealing with and capable of making them successful. Majority of our projects are successful. I can hardly count, I probably can count on fingers unsuccessful projects. So students are taking it very, very seriously. Now, of course, you don't know exactly what you want to do after graduation. For example, you can either decide to go to grad school or to go to academia or do something else, something that I'll mention in a moment. But all in all, you have to try many different things. So you have to try yourself doing research. Maybe you will like it, and to continue your education and possibly getting a career in academia. So you would have to get involved in research at some multiple faculty labs that we have, or maybe you do some summer research at other universities. Uh, Now, in order to continue in academia, of course, you would have to go to a grad school. And of course, GPA should be very, very high to get accepted. So even though here I indicate the lowest GPA of 3.0, I would say to get to get a master's degree, the lowest GPA probably would be 3.2 to 3.4. In order to get to a PhD program, most likely your GPA should be greater than 3.5 at least. So what can you do after graduation? So what are the school paths that you can take? So you can continue in the grad school to get yourself a master's degree and continue on getting a PhD degree, either computer engineering or computer science if you wish. So, for example, if you were involved in intelligent systems focus area, most likely you can seek a PhD degree in computer science. Or you can decide to get yourself a work experience. Or, as many students actually do, they get themselves an MBA degree or Master's in Business Administration. So eventually they become product managers, marketing managers, executive managers, or some students actually go to a law school. So if they want to become patent attorneys, uh, intellectual property attorneys, so that would be a good, you know, choice. In fact, it is not unusual for our students to enter a law school, and especially MBA. So we've got plenty of students who got MBAs and got jobs in Silicon Valley. All right, so those are the paths that you can take. Now, if you go to industry, so you can be involved in multiple things, doing multiple things as an electrical engineer. So, for example, you can deal with research and development, you can deal with design, systems engineering, or you can become a test engineer, field engineer. As I mentioned already, you can deal with systems engineering, for example, working on for big companies like Boeing, NASA, or you can be in sales, promoting technological products. For example, technical marketing, product marketing, and your positions would be classified as engineer, senior engineer, staff engineer, chief engineer, or chief scientist, and so on and so forth. So there are multiple opportunities for students who graduate with even with a bachelor's degree. So that's pretty much everything I wanted to tell you. So you're welcome to ask questions if you have.
Well, we have a lot of questions.
Okay, I would be happy to answer them.
Okay, so we have, how does the department, I'm assuming electrical engineering department, support students interested in pursuing research or innovation in different emerging fields?
Well, first of all, our faculty is always working on uh, on on the most contemporary technologies. So as far as encouraging other students, or there are plenty of opportunities, as I mentioned, in our research labs. So you simply would have to contact your faculty of ECE faculty, and most likely they will have an opening for all types of students, freshmen, junior, senior, sophomore, senior. It will be up to you if you want to pursue that objective or not. But we have plenty of opportunities to work on the cutting edge technologies because our faculty works on cutting edge technologies. So they are well supported by funds, by National Science Foundation, by industry, such as Google, Microsoft, Facebook, you name it. And most likely you will see that our faculty has support and grants from those companies. So hopefully that answers the question.
So how does UCR's EE curriculum balance theoretical learning with practical hands-on experience?
So let's put it this way. Before we do hands-on experience, we need to have a good theoretical background. Because without a theoretical background, new things cannot be, you cannot be at the cutting edge of technology because you don't know what a cutting edge technology is without a good theoretical background. And hands-on experience you obtain in multiple of our classes, in circuit designs, RF circuit design, control systems, robotics, uh, logic design, embedded system design, almost all areas that I mentioned as our focus areas deal with hands-on experience. We have labs related to providing all facilities to improve this important expertise.
The next question is, do you know if other UCs do these kinds of Zoom meetings for the, actually, I can answer that.
I'm not aware of it.
I'm going to say that this is the first time that we've done this at UC Riverside, and the BCOE College of, like the Bournes College of Engineering, is the only college at UCR that did these kinds of major specific information sessions. So, you know, if you find one of the other UCs that did this kind of innovative programmatic presentation, send me an email. My email is Christina, Christina at ucr.edu. I think it's going to be really hard for you to find somebody that did this. So the next question is the 3 to 4 hours in addition to the time in lectures, or does it include that?
It depends. It depends on the class, but I would say that this is beyond lab and lecture hours.
Okay.
So which means you have to spend 3 or 4 hours per unit of additional studies.
And then the last question, is it possible to have a work-life balance given the intense workload?
It depends on time management. Typically, work-life balance should be kind of, how would properly phrase it? Education is hard. So of course you cannot have a work-life balance that you would have without not going to school. So it is not 9 to 5 and that's it. So you will have to we have to spend 4 years actually, not having a work-life balance that you would expect otherwise. So, but again, it all depends on on time management. And one of advantages of going to school is you actually learn how to deal with stress, how to properly manage your time, how to develop self-confidence, and so on and so forth. So those are probably four the most important years in your life. So thinking of work-life balance during studies, I wouldn't think of it like this. They spent these 4 years to study because 4 years is not a long time, but the benefit of it will be tremendous.
So these are the end of our questions. So I'm going to be ending the webinar soon. But what I wanted to put in there for those of you who are curious about, research opportunities, internship opportunities, or any kind of, like you brought up work-life balance. What does that look like to me? Our BCOE student success unit is giving a presentation tomorrow at 4 o'clock, and it'll be about 45 minutes. And this is the team that's dedicated to undergraduate student success, and they work with all of the students and the student orgs, and they'll be able to talk in detail about how they work to match undergraduates with faculty researchers and how they help in that area. So if you're interested, I encourage you to attend that session tomorrow. And if you have any questions, please visit admissions.ucr.edu, and those would be questions related to applications or related to financial aid or scholarships or admissions types questions. They have a chat that's staffed until 10 p.m. and they can answer those types of questions. But thank you so much for joining us and attending this presentation. And have a great long weekend.
And thank you, Christina, for organizing it. Thank you so much.
My pleasure.
Bye-bye.